Today, we build, ship, and share multi-agents. So, Wiz, Swarm sounds pretty serious and for real. Is it that serious and for real?
I don't know if it's so serious, but it's definitely for real. Yes.
Oh, so you mean OpenAI getting into the multi-agent game bodes well for the future of AI engineering? Something like that?
Yeah, I mean, if we look at the history of OpenAI and their contributions, a lot of the time we wind up kind of, you know, approaching standards that they set. Thinking about problems in the way that they, talk about them. They're very opinionated, which is extremely helpful. So I think Swarm's a good signal coming from OpenAI and provides some primitives that we might see gain some traction in this space.
Some primitive. So are they doing anything like super different than when we look at like Crew AI or LangGraph or LlamaIndex agent frameworks? Is anything really truly unique happening here in Swarm?
Uh, no, it's kind of more of the same, but it's done through this specific opinionated way, and I think that's the where the value comes from.
Okay, so we'll take a look at Swarm based in first principles first. And then let's see if we can't group the different frameworks together around those basic concepts. Let's see if we can't swarm our way into understanding Swarm. You think we can, Wiz?
Yeah, I think that sounds pretty dope. Yeah.
And then you think we can leverage OpenAI's truly open AI library now called Swarm to build some multi-agent systems?
I definitely think we're gonna do that.
Dope. Let's fly. All right, Wiz, we'll see you back in a bit. Okay, welcome everybody. I'm Dr. Greg. That is the Wiz, aka the LLM Wizard, Chris Alexiak. And we're here to talk about Swarm. This is one of the latest releases from OpenAI, and it's a multi-agent orchestration tool. If you've been following multi-agent orchestration tools, it's not the first, but it is the first one from OpenAI. We wanted to take a first look at it. It's supposedly just for education, not for production. What does that mean? What are the core constructs? How do they compare to ones that you may have seen and built with before? That's what we get into today as we take a look at Swarm. If you have questions along the way, please drop them in the Slido link, and we will do our best to answer all of the most upvoted along the way. All right. As we align ourselves to the sesh today, we want to walk away understanding the two core constructs of Swarm. One is routines, the other is handoffs. We want to also build a couple of multi-agent systems with Swarm, one boilerplate, one a little custom, and then we want to try to meaningfully have like a cool discussion that compares Swarm to other leading frameworks and their core constructs. So if you've been following the channel for a while and you're into LangGraph and LlamaIndex workflows and Crew AI, this is going to be a particularly interesting discussion, and we look forward to having it with all of you guys. Let's introduce Swarm by introducing agents first and foremost. And in order to do this, we're going to take a slightly different cut than we typically take. Let's approach agents first by offering our definitions, some AI Makerspace definitions. We can define an agent or an agentic system as a system that can leverage or emulate reasoning or equivalent processes to make dynamic decisions in an application flow. We're always concerned with constraining ourselves to the world of building useful LLM applications, not simply going off and doing a ton of research on multi-agent systems in general. So if an agent is a system that can leverage reasoning to make dynamic decisions, then we can say a multi-agent system is a system that can leverage reasoning from multiple independent agents to make dynamic decisions. Simple as that. Agents, of course, are not a specific thing. They are a pattern. And this pattern is one that you might know as REACT, the reasoning action pattern. This paper really kind of led the way on agents, came out October 2022. And if we look at sort of what the paper outlined at that time, they said, if we look at these traces, we look at how the application flow is going, we look at the reasoning steps, we can see that the reasoning can help the model to do all sorts of things with planning, dope, but also can interface with and gather additional information from external sources. This is the key. This is really one of the things that is becoming the standard, and we want to zero in and zoom in on this just to make it as clear as possible for all of you today. When we think about the reasoning action cycle, the agent cycle that we're typically going to be using to build these applications, we ask a question, we go to the agent. Maybe the agent knows the answer straight away. In that case, it's basically a simple LLM call. Doesn't really need to be that intelligent. More generally, the agent is going to then reason to take an action. That reasoning and action pattern, that loop, that cycle, is really at the core of what we call agentic behavior. Now, we might reason that we need to go take an action, we act, we observe something, we consider that additionally in context, and then we produce our final answer. But maybe we need to loop through a few more times. Maybe we need to look at specific actions or specific tools that we might pull out of our toolbox. Those tools could be proprietary data RAG systems. They could just be search APIs like Tavily or SERP API or DuckDuckGo. They could be a lot of different search and retrieval tools. And when we actually call a tool, when we call a function, we're getting some result. That result is what we observe, and that result is added to our conversation thread for the next reasoning step at the beginning of the cycle. So I want to zoom in here for a second, and I want you to focus on this piece. We're actually doing this LLM call on a fine-tuned LLM, one that's been fine-tuned for function calling, for tool calling. Let's zoom in. If you notice here, the reasoning step and the tool or function calling step kind of go together. In fact, what happens is at this interface between the reasoning, the agent, and the action, calling the tool, calling the function, is exactly function calling. What am I saying? I'm saying that function calling combines reasoning and action. Function calling combines reasoning and action into a single step. That's what function calling does. So let's disambiguate a little bit more language. Is function calling the same as tool calling then? Yes. Function calling is a more general, more abstract way to represent tool calling. We can think of agents as simply giving the LLM access to tools. We can think of agents as simply function calling. Of course, because function calling is a tool, because it calls the function. The language is tough to get around here, but stick with me. What about multi-agent systems? Is it the same thing here? Are we just dealing with tool calling, function calling, consider the most popular way to set up agents in a multi-agent framework with an agent supervisor approach, where the supervisor delegates tasks. Consider that the agent supervisor delegates, and supervisors are simply just picking these routes. Supervisors, in other words, are just routers. So then a multi-agent system is just a router on top of other agents. By the way, a router is in the end just a function call. So supervisors themselves are just function calling agents. So are you telling me that it's function calling all the way down? Yes. You know what else is function calling all the way down? You guessed it. OpenAI's Swarm. Wiz, I want to bring you up for a second, have a quick discussion here. We just went through a bunch of terminology. Agents, tool calling, function calling, React, multi-agents. I thought agents were like something that was more complex than just function calling. Is that actually true or not?
So it can be true for sure, Greg. And I mean, it doesn't need to be untrue. But when we look at agents in their purest form, in the way they're used most often, it just winds up being tool calling, function calling, however you wish to call it. And that's because it's a very simple, straightforward way to give access to the LLM to do things, right? Which is what it needs to go from LLM call to agent. We need to be able to do things. And so, yes, I would say they can be more complex. We can add more sugar on top of it, like planning and then execution and all this other stuff. But at the end of the day, we're just building a list of function calls to make, and then we call those in some order as determined by the LLM.
That's right. That's right. I mean, because if we go back to the OG here, help the model induce, track, and update action plans. This is another piece that I see getting called out. For instance, when I was looking at LlamaIndex docs, preparing a recent workshop of ours, there's this piece that also is sort of more based in the reasoning piece. But this, again, going back to the react in one boom step, that's kind of at the core of why this has almost become more or less agents equals function calling in my mind. Is that a reasonable way to think about it?
Yeah, absolutely. We need to think about an action, and then we need to do an action, right? And so at the end of the day, this do an action can be expressed in a number of ways that all kind of lead back to or trickle down to we got to call a function, right? We need to execute some code or do some process through a function.
That's right. And you know what? That's a great segue into what's really going on with Swarm. We'll see you back shortly, Wiz. When we talk about Swarm now, when we talk about this latest from OpenAI, there's two pieces, two easy pieces to Swarm: handoffs and routines. Now, the language here, just track it, because it'll come back into play when we start looking at what is happening across frameworks. But if we look at first routines, okay, you'll see why we're choosing routines first shortly. A routine is, quote, not strictly defined, but it's meant to capture the idea of a set of steps. According to OpenAI, a routine is simply a list of instructions represented in the system prompt, along with the tools. Here's the instruction. Here's the tools. Sounds pretty straightforward. Now, it's also important that you note that in some of these examples, you'll find in OpenAI that I've highlighted here words like first, only if, and if, classic conditional words. You're going to find that within the system prompt, you're actually getting this sort of if-then kind of hierarchy designed for you. You're getting that sort of planning designed for you. And this is not uncommon. This is not something that is unique to OpenAI, but it's something that's worth noting when you're really trying to grok the true complexity of these systems. At the bottom, it's not really all that complex. It's simply giving specific good instructions, classic prompt engineering. So a routine then is basically this set of steps, these conditionals. Well, what's a handoff? Well, a handoff is, quote, an agent. It's, quote, or a routine? Well, long form, a handoff is an agent or routine handing off an active conversation to another agent. What does that sound like? It sounds a little bit like a supervisor, doesn't it? Sounds a little bit like function calling all the way down, right? Now, once an agent decides to hand off, it's time to make it happen. Once an agent, in other words, reasons to make a handoff, it's time to take action. Right? So here we are, handoffs and routines, reasoning action pattern, function calling makes it one step. These were, quote, as a proof of concept, packaged into a sample library called Swarm. Friendly reminder, it is meant as an example only and should not be used in production. However, they say, feel free to take the ideas and code and build your own. We will. Let's remind ourselves about the supervisor agent thing real quick. Like, why would I actually need this? Why would I need a swarm? Why would I need a multi-agent system? It's typically used where we're grouping responsibilities and we're separating steps fundamentally. We're separating the pieces of the plan within a team. And it's useful to have this for a conceptual model. It looks a lot like the way business is done in organizations. It looks a lot like the way business is done throughout different types of teams. We're going to look at two types of teams today. First type is we're going to build a news team. We're going to have a main anchor that's going to kind of be like in the center. And then we're going to have access to weather, have access to sports, and we're going to see if we can, build a little news team here, build a little news swarm. We'll also look into, and this will allow us to look into some foundational concepts within the library as well. One of the default library examples, which is an airline. And they have sort of a meta agent here, which is called the triage agent. The triage agent is the supervisor agent, right? It's sort of figuring out where to go, where to route, where to triage to next. And then, if you're calling an airline, this is like customer support. Maybe you want to mod your flight. I certainly had to do this recently. Maybe you lost your bags. I know Wiz had to do this recently, so it kind of hit a little bit close to home here. And we're going to look at this one as well. So we'll see, what is the value of building a swarm versus just doing a single agent here with news team and with airline from the Wiz take it away, my man. Swarms with OpenAI. Let's see the code before we dive into how everything compares to other frameworks when we're done.
Yeah. Okay, so Swarm. You know, it should come as no surprise. The code's not that hard. They built this to be educational. They built this to be easy to use, and so it is those things. First thing we're going to check out is how we get Swarm. We get it from the repository, as Greg showed. It's easy enough. We can just pip install it right from the repository. Again, we have this not for production flag. So, don't go out ASAP and try to put this into prod. It's just not built for that. Who knows what will happen in the future? We are going to provide our OpenAI API key since, unsurprisingly, this uses API or OpenAI as a default for the LLM powering the agents, being that it's from OpenAI. Okay, so we have a basic introduction to Swarm. Swarm is built from two main components. One component is called agents. One component is called handoffs. When we think about agents, it's pretty straightforward. When we think about handoffs, it's pretty straightforward. So combining these things shouldn't be too complex. And we'll see that in fact it's not. We do have to start our client. This is just necessary. Without the client, we can't send requests to OpenAI. The first example we're going to build is a very straightforward example of a local news team. We're going to have a main anchor, a weather anchor, and a sports anchor, and we're going to create some agents for each of them. The main anchor agent is going to receive some instructions. The instructions are going to contain what's called a routine. The routine is essentially just things you do in the order you do them. The routine can be manually created, as you're seeing here, or you could have an LLM generate a routine and then pass it to a dynamically created agent, right? So you can kind of start to think about where this can go. We're just going to keep things simple, though, and define a simple routine. You'll notice we can also pass in context, which is close-ish to state. It's not like too intense, right, of state. It's not like, LangGraph. It's not like LlamaIndex is, event-driven context. But it does let us have this idea of something that we can persist, that can modify things between steps. And so you can again imagine this being leveraged to great effect when you're building more complex workflows. Okay, so the instructions are very straightforward. They just pull from these context variables, which we pass in when we run the agent. The actual instantiation of the agent couldn't be more simple. We name the agent and we give it some instructions. Okay. Now we can invoke the run method. You'll see in the run method that we're going to pass in this local context, which is going to contain the local context key, which says Toronto and today's date, which is just some random date in 2018. So the LLM has a better shot of answering or, producing things that are close to it. Then we need to start things off with a message. I'm just using this generic kickoff message, which says begin the newscast. As you can see, our main anchor's routine is very straightforward. Talk about events that occurred on or before today's date. When you're done talking about events, pass to the weather anchor. If the weather anchor has already spoken, pass to the sports anchor. If the sports anchor has already spoken, conclude the broadcast. So basically, it's just a local news team. They kick from one to the next, easy peasy. Okay. For local context, we're going to provide again Toronto on July 1st, 2018. And then we're going to pass in those variables. We're going to pass in our named agent, and then we're going to put debug equals true, so we get this nice little debug statement. And we have, good evening, I'm Peter Jennings. Welcome to the Toronto Evening News. First, a poignant moment in the city as thousands gathered at Nathan Phillips Square to celebrate Canada Day, and on and on. So the idea is, it's just going to produce a news broadcast based on the information we pass in. Not so complicated. Okay, let's next create a weather agent. The weather agent is going to need access to some kind of tool, which it can use to determine what the weather is. We are just hard coding what the weather is, though you can hook this up to an API, straightforwardly. But the idea is that it's going to call this tool, and it's going to say the weather in region is an 18 degrees Celsius with light winds and is clear. Okay, nice. Then we're going to go to create our new agent. You'll notice the same thing we did before. We pass in a name, we pass in some instructions. The instructions contain our routine, and then we also pass in this extra piece, which is our functions. And in our functions is our weather tool. So you can see now our agent has access to a weather tool, and the weather tool is going to be used to help us determine what the weather is. And again, while it's hard-coded right now, it could be dynamic, and that's the whole point. We're going to then call this and see what happens. We say, you are in Toronto as our kickoff message. And we say, oh, what a delightful day it is in the vibrant city of Toronto. It's 18 degrees Celsius, which is just the right temperature for a playful stroll or perhaps a joyful jog through the parks. The winds are light, so you don't have to worry about chasing your hat down the street, etc. The basic idea being that it calls the tool, as we can see here. And then it responds. So the idea is straightforward enough, right? This agent can call some tools. Now, we're going to kind of wrap this together through what's called a handoff. A handoff is basically just a way for us to transfer messages between agents, right? So we have our weather agent right now, and we have our main anchor agent, right? So we have these two agents. And they don't talk to each other at all right now, and we want them to. And the way we do this is through a handoff. And the way we create it is just like this. Pass to main anchor, return main anchor agent. That's it. That's all we have to do. So essentially, Swarm is handling the rest for us, right? It's handling the message history that's being passed through. It's handling anything else that needs to happen. All we have to do is create like a link, right? Or an edge, if you want to get graphy about it, between that agent and another agent. So that's what that handoff is. Okay, so now we have three handoff functions, right? And the way that we can characterize a handoff function is basically just that it returns an agent. Then we are going to create two tools, our weather tool, which we've already created technically, and our sports tool, which we're creating freshly here. Then we can see what our kind of agent looks like. The agent looks like this. We send a message. Our main anchor agent is going to pass to our weather agent, who passes back to our main anchor agent, who passes to our sports anchor agent, who passes back to our main anchor agent, who gives us our final response. But you'll see that this is essentially just a graph, right? We have described our system as a graph, which is visually helpful, and also is a great way to think about it, right? Each of these agents are nodes, and we connect them through handoffs or edges. All right, so how do we actually create all of this? This is exactly the same as we saw before, except this time, instead of passing no functions, we pass in our two handoff functions. So our pass to weather anchor and our pass to sports anchor. Our sports anchor is going to contain both our pass to main anchor and our sports tool, and our weather agent is going to contain both our pass to main anchor and our weather tool. Right? We never have a situation where the sports anchor passes to the weather anchor, so we don't need that to be a valid edge. All we do is we go back to the main anchor. We then can run this with debug equal true, and we can see the whole thing. We get chat completion for the main anchor, we receive the completion. Then we process pass to weather anchor. Then we get the weather anchor, who calls the weather tool. The weather tool completes, and we pass to main anchor. Then the main anchor passes to the sports anchor. Then the sports anchor calls the sports tool. Then the sports anchor calls the pass to main anchor. And then the main anchor closes us out, completing the broadcast. And that's the whole thing, right? So we can see how this looks in actual text here. Good evening, Toronto. This is Peter Jennings, etc., etc. That's a wrap for city highlights. Let's turn our attention to Mother Nature as a start by passing it to our weather agent or anchor. And then here we say, hey there, Toronto, you're goofy and fun-lovely weather anchor here, and I've got some delightful news for you. We currently have lovely 18 degrees Celsius, etc. Back to the main anchor, and then the main anchor passes to sports. Easy peasy. So this is the idea of Swarm, right? And that's kind of the most simple version. So let's look at a more advanced version, which is going to be our airline agent system. Our airline agent system is going to be very just an extension of what we looked at, right? So we have the main agent or the triage agent, which is similar to the main anchor agent. It just acts as a router. Where do we go next? What do we do next? Where do we go next? What do we do next? User says something, I'm going to get you to the right place, right? Then we have our flight modification agent, which is going to contain two sub-agents, either a cancel or a change agent. And then we have our lost baggage agent. In order to create our flow, we need to have a bunch of prompt templates, right? We have to have a bunch of prompts that indicate what we're doing when. So for our triage system prompt, here we have it, easy peasy. It's basically just you're expert in triaging. You can pass to these people. That's it. Then we have a policy for each of our sub-agents. So we have a baggage policy, we have a cancellation policy, and we have a flight change policy. We communicate the policy through these routines. You'll also notice that we have this starter prompt. This is the same for every single policy agent, right? So for every agent that has a policy, you can see here that we have the same starter prompt. So they reuse this. Basically, it's like a boilerplate. Then we set all the policies, which look a lot like routines. Once we've completed our routines, we call the case resolved function. Then we can create our handoffs. Our handoffs are very straightforward. They just hand off to those agents, right? So each of these is an agent. That's all we do. Then we have to create our tools. Again, these tools are just hard-coded to keep it simple for the example, but the implementation is totally extendable. You can do whatever you'd like. And then finally, we can create our agents. Our first agent is going to be our triage agent, which can pass to our transfer to flight modifications or our transfer to lost baggage. Then we get this graph. So this is the initial graph, and we're just going to grow this thing as we move through the examples. So we take in some initial message, which goes to the triage agent, and then we do some actions, which could include transferring to flight modification, transferring to lost baggage, or asking the user for more clarification, which will then loop back in. Technically, all of the nodes ask for user response. I'm going to put this at the end of the graph to keep things less messy while we build this graph, but every node will pause at the end of its turn and ask for user messages. So the next node we're going to ask is the flight modification agent. Now, the flight modification agent doesn't actually do anything. It's just another router, right? So we have our initial triage router that routes to our flight modification router, right? Which is going to either choose cancellation or it's going to choose change. And so we have these two: transfer to flight cancel or transfer to flight change. You can see here, all this does to the graph is it adds another node, which has another two potential outs. Then we're going to fill in that final piece by providing our flight cancel agent and our flight change agent. Now you can see we have this situation. We have our triage agent, which can go to our flight modification agent, which can go to our flight change agent, or our flight cancel agent. Those will use their tools to collect, deliver, and do things, and then we will send back to the triage agent, or we will send back to the user response. Both are possible, but again, I'm just leaving these paths out of the graph construction. They'll be added at the end to keep things less messy. Okay, so now we've added the final agent, which is our lost baggage agent, which has, you'll see that each of these have a number of different tools or functions that they're able to call, right? So we once again add to this diagram, and this time we've added the user response piece more explicitly, though it does clutter the graph a little bit. We have this ability where our triage agent can now either ask the user for clarification, go to our flight modification router agent, or go to our lost baggage agent. And those agents can talk to the user, or they can send back to the triage agent. They all have access to the tools we defined when we constructed them, and that is it, right? So finally, we can use this. You'll notice that this cell is errored just because we're running this in Jupyter Notebook. I have to Control-C to end the interaction, which makes it stop. You can see here that the warning is actually interrupted by a user. So it didn't run into an error. It's just the interaction was complete. You'll notice that this doesn't have like a end node, right? So if you wanted an end node, that's something that you'd have to include yourself. But we can ask the whole questions, right? So we can say, hello, I'd like to change my flight. Then we transfer to flight modification. And then we say, can I push my flight back 1 week? And then we go to flight change traversal, right? So we're no longer at the flight modification agent. We've gone to the flight change agent, right? So what that means is that we went through one router to the next router, and then that routed us to the agent we cared about. Then we get the valid to change flight tool called here. They check for, they check. There's no actual checking here. They just make up that it's possible. Since there's no actual API it's hitting to see if it's possible, we just always return, yep, that sounds good. And then we change our flight. And then finally we get our case resolved response. So this is one flow. A second flow, if I want to cancel my flight, can I cancel my flight? Then we get the transfer to flight modification, transfer to flight cancel, right? So we just pass through our flight modification agent because there's nothing to do here, right? It doesn't need to do anything other than get us to the right agent. And there's enough context here to get us to the right agent. And then we ask to cancel, initiate refund, case resolved. And that is Swarm. That's how we can use Swarm. This is one of the examples that we can use Swarm for. But the basic idea is that there are agents that we set up, and the agents have the ability to do these handoffs to other agents. So we have the triage agent handing off to the flight modification agent, and you'll see that it persists that message history throughout. So this is extremely useful because it gives all of the context the next agent needs to from the previous agent. And with that, I'm going to pass you guys back to Greg. But before I do, I've got to ask you to subscribe and hit the little bell icon. We're live every Wednesday at the same time. We love doing these videos. So thanks so much. And with that, we'll head back to Greg.
All right. Thank you, Wiz. So that's Swarms, everybody. We now have kind of covered how to build with the framework. We've shown a bit about how the framework kind of came to be with the agents and function calling connections. Let's now move to looking across orchestration tools to see if we can get any new insights. And let's quickly look across a few that we've mentioned. The first one is Crew AI. And Crew AI is a well-known multi-agent system for framework for building multi-agent systems, enabling AI agents to assume roles, share goals, and operate in a cohesive unit. Okay, great. But what is at the core of Crew? Well, they have agents, tasks, and tools. Altogether, these make up crews. Processes are kind of abstracted from us. Agents, tasks, tools, crews. What about LlamaIndex? Well, LlamaIndex recently put out workflows. Now, workflows isn't explicitly only for agentic systems, but it does allow us to add cycles. Now, this is an event-driven approach, but we end up seeing that workflows are an event-based, event-driven, step-based way to control these kind of agentic loops, these execution flows that are a little bit more complex. So there's, just as in Swarm, there's two easy pieces to LlamaIndex workflows. And we've done events on all of these frameworks in the past if you're not familiar with them. But let's add one more so we can have a robust discussion here. Finally, LangGraph. LangGraph is, quote, a library for building stateful multi-actor, multi-agent applications. And it allows us to do that by adding cycles to applications that we've built in a more traditional pipeline-driven way. So LangGraph, in opposition to the event-driven approach used by LlamaIndex workflows, is actually explicitly using a graph-based graph traversal algorithm. We assemble the graph. We don't just leave all the possibilities up. The graph is built with nodes and edges, where the node, each node is like the thing being called. It's the function. It's the tool. It's the, in LangChain expression language, the runnable. And for those of you less familiar with LangChain, every component of a chain is a runnable. The entire chain can be a runnable. Runnables are sort of a first-class citizen in LangChain. And just as nodes are sort of the action, the thing that gets run, the edges are where to pass state to next. So we're sort of figuring out where to go. All right, so we have this sort of where to go, why to go there, this reasoning piece. We have the what to do when we get there. We have this action piece. And we can look across all four of these. This is a terrible slide, okay? Terrible slide. But I want to bring up the Wiz, and I want to just walk through this for a little bit here. So Wiz, we talked about routines and handoffs today. We can make up swarms with them. We've talked in the past about giving agents agency to deal with tasks and tools, like in Crew. And we've recently covered LlamaIndex. You know, we heard today that a routine is basically a set of steps, right? Oh, look at that. LlamaIndex is just called steps, right? And so we can kind of start to draw these parallels across frameworks here. I'm not even quite sure what to label these parallels yet, but does it all go back to React? I mean, how do you think about the meta pattern across these multi-agent frameworks that we've looked at so far?
Yeah, I mean, like, okay, so it's true that routines are steps, but they're like prompt steps, right? They're not literal programmatic delineated steps. I think that's some of the lightweight framework, right? Where Swarm has this just as a prompt template with literal numbered steps in the prompt. Something like LlamaIndex or LangChain is going to allow you to actually literally create different Pythonic functions for each step, right? So it's that expansion of the process. Technically, you can do that with Swarm, the agents, right? You can compose them such that they look an awful lot like steps, but routines themselves are just basically in Swarm they're called agents, and they just are prompted. I think though this kind of we're seeing things lining up here. Definitely when we look at this kind of a chart, right, where we have this idea of we do a thing, then we pass that thing to the next thing, which does a thing, which passes that thing to the next thing, which
does another thing, and then
yeah, sounds an awful lot like a chain at the end of the day, right? Or some kind of graph. But the way we're implementing things are starting to condense. Yeah, that's basically where I'd be at.
I see.
Yeah.
Well, interestingly, I'm seeing some stuff in the Slido here. Like, it's a fun one. Like, are you aware that Crew AI now also has flows? It's like, well,
yes.
Well, like, I guess it's not really that surprising when you look at a chart like this. It's like LlamaIndex just put out workflows. I wonder what flows is. I don't actually know right now, but you know, it's like we're starting to see, and I think the point that we want to make here today is that we're starting to see this almost this convergence, this maturity of the tools in the space. We're starting to see some one-to-ones. We're starting to see, even if it's not one-to-one, I see the overlap. I see the pattern, regardless of construct, and I see sort of what's at the core of these applications themselves, which in the end seems to, you know, be function calling, right? And it seems to be aka tool calling, aka, you know.
And I think too, like there's this amount of enforcement or it's not guardrails, so I can't call it guardrails. So that means something else. But train tracks, let's call it, right? So there's an amount of train tracks in some of these more mature, some of these more advanced frameworks that are not focused on being ultra simple and lightweight, in which we can be very explicit about the paths through, versus something like Crew AI or Swarm, which are less explicit. Though Crew AI through flows now lets us be more explicit about how we define how our agent navigates through potential workflows. Unsurprising that we have term overloading there, right? I do think that at the end of the day, for all of these agent frameworks, though, we're getting to the point that it's function calling, passing through, we have function calling that goes through programmatic steps. Where at each step, we have a potential end functions that we can call, but then we go to a next step based on the response. And that is something that I think the maturation of the space is giving us, like, we love the flexibility, right? But we can't stand complete non-determinism where like it'll just do stuff. We need to be able to say, this is a valid path. This is a valid path. There are no other valid paths, regardless of what the LLM says. And I think that's what these frameworks ultimately are helping us to do. And that's achieved in large part through function calling.
Okay, very nice. And so then, if we sort of drive home the last point that we were kind of very interested in making today, I'll just have you stay up here for a minute. It's like if we think back to the earliest days of building LLM applications, we can think of the OpenAI API, and we can think of the tone that they set with the system user assistant chat style model. Now we call them chat models. They're always tuned for chat. We're using this sort of system user assistant kind of thing, whether it's open source, closed source. It might be a little bit different in the implementation if it's Mistral or if it's Llama, but it's the same sort of idea. And so this sort of chat style model where we have these roles, system user assistant, this kind of really set the tone for the maturity of what came next. LangChain, of course, said, well, actually, I'm not going to call it, I'm going to use system and user, but I'm going to call it the AI instead of the assistant, right? And so it's a little bit more intuitive, a little bit less jargony. Now we're hearing that routines, check this out, a list of instructions included in the system prompt, along with the tools. So we're seeing this sort of potential maturity of the space with the bringing in of Swarm. This is one of the things that, we're kind of excited about, because it's kind of like now that OpenAI has stepped in, I think it's more likely that standards will start to be really set with this terminology. So we're not stuck in disambiguation word soup land all the time anymore with agent and multi-agent systems. Something like that. Is that kind of, is that stating our point of view on this well enough?
I think, yeah, the crux is that OpenAI set a standard for API, their OpenAI API spec. OpenAI has clearly set the standard for the way we are thinking about system user. And I think that while we're certainly not going to stick with their names of routines, which is decommissioned, and we're now saying agents, and then handoffs, those ideas are exactly correct. Where we have an agent that does things and it hands off to a different thing, which could be an agent, could be a process, but this is the idea that we have. Agents do stuff, and then they hand off to the next step or one of possible next steps. And so I think seeing them come out, be this opinionated about this, encourages me that the kind of industry is settling around this pattern as a way to go forward together.
Yeah. Well, I'm excited for what the future holds and trying to get to the bottom of it, whether it's state or function calling or whatever it is, sort of at the bottom of all these frameworks is something that we'll continue to investigate here at AI Makerspace. So we're going to go straight to questions. There's a lot of great questions. Please use the Slido today, because we're having a little bit of trouble seeing the YouTube chat with the new StreamYard update. Today, we saw that agents and multi-agent systems, function calling all the way down, basically react in a single step. We have quite a lot in common going on between the various frameworks, and we've got a great set of questions that we're going to start digging into now. So please upvote your favorites. Quick question that's kind of a follow-up on our discussion. How is Swarm different from LangGraph, and how state graphs are, how can we sort of track state with Swarm?
Yeah, so through that context variables, we can do this, though it requires a little bit more of a heavy lift on our side. But the basic state that's tracked is just the message history. Anything past that, and it's going to require you to do a bit more programming. But that's it. By default, the only state that exists is the message history, and it is shared through the handoff in full with every subsequent agent that is handed off to.
The only state that exists is the message history. Okay.
By
So
default.
it's kind of similar to the rolling conversation thread that we saw in OpenAI Assistance API.
Yeah, say message history, memory. This is the thing we've been doing. All the same thing.
Yep. Same. Okay. What are your thoughts, Wiz, on OpenAI and Anthropic computer use launch yesterday? I'm not sure what that means, but I hope you do. Launching their own agents. Will they replace the current frameworks? Prediction.
No, I think they use agents to do what they do, right? So computer use is what I just saw this from a Verve article or whatever, but like it's what Rabbit MR1 or whatever it was called was promised to be, right, with the computer use agents. But they're just using agents, so it's not like it's not there to replace agent frameworks. It is a downstream use of agents, right, whereby the model has access to what's happening on the computer and can do things on the computer, right? So while it is fantastic, super cool, definitely something to talk about, be excited by, it's not like a replacement. The same way that OpenAI, ChatGPT like isn't a replacement for RAG, even though you can upload pictures to it, upload text to it. It doesn't replace RAG. It's a utilization of RAG. But it is super cool. Hard to agree on that one. Yeah.
And and then inevitably, right? Nobody wants to put their good stuff in front of Anthropic and OpenAI, so they're not going to replace any of that enterprise open source vibe, love that we're seeing all the time. Okay, can we put Swarm in a full stack app? I think immediately I'm thinking, well, they told you not to manage several conversation threads. If so, how? With a disclaimer of don't do it, perhaps.
Yeah, I would say don't do it because they say don't do it. But basically, like, you just handle that through handoffs, right? So we can at some point determine what we're going to be handing off, how we're going to be handing it off, what happens inside the handoff. And so several conversation threads would need to be managed by you, the programmer, not through Swarm. But you can cook up a system where you store them somewhere like in Redis, and then you pull the ones you need or want as you're going through.
Yeah. Okay. Maybe we can just comment on this again. Looks like this is going to shut down many agentic frameworks. I mean, it's got the dopest name. Okay. And it's not the first place to use Swarm as a name, but it's OpenAI. So if they call it Swarm, they get Swarm, just like they got OpenAI. I mean, again, like the enterprise thing, enterprise is locked into whatever they're locked into. They want open source flexibility. You don't get that with OpenAI. Do you have any other thoughts that we haven't shared yet on this? I mean, dope naming aside.
OpenAI has yet to shut down a single framework because they're not a framework company. This is cool, and this is the start of a lightweight framework that they might keep working on. It might wind up being eventually able to be used in production. But I mean, right now there's no path to production.
So I'm just thinking, if we think about their path from LLM OpenAI API into function calling API, right? Do we get to this place where there's going to be like sort of a multi-agent function calling API, right? That there's an input, the standard to a multi-agent system. And it's literally within the OpenAI business model, because you said they're not a framework; they're a tap into our APIs company, right? Maybe framework meets model. Does that make sense?
Maybe, yeah. I mean, could be. Without knowing their plans, I think This is something that their solution architects came up with for some customers, and they decided it was good enough to publish it, to get people tinkering with it and contributing to it. I don't see this being something that's meant to compete in that space as much as it is, this is how we're doing this. This is how we're approaching this. Same thing they did with their SDK, right? Their Python SDK at the start of the ChatGPT times. It's great. It's a good tool. I imagine other frameworks might leverage some of these tools, but I don't see a future where they are trying to make this their thing, other than it's dope. And their opinion is important to a lot of people who are building with these tools. So
Yeah. Well, and it clearly, makes a big impact on even our audience, thinking that they're going to shut down all the agentic frameworks, out there just because OpenAI came out with one. That's kind of super interesting to see. So, we get this question a lot. It's a classic one. What are the examples of large scale systems with agentic frameworks in production now that come to mind for you, Wiz? I mean, we talk about this often as multi-agent systems in production are not really a mature thing. It's very, very hard to find examples. But when you think of agentic in general frameworks in production, what do you think of?
Yeah, that's a wonderful question that has no good answer or yet super real answer. There are companies who are working on this. Agentforce is, I think, the cleanest example of clearly using agents in production. Their framework is whatever they've disclosed it is. But at the end of the day, this kind of library from OpenAI showcases, right? It showcases that we're not yet at the point where we're building very maintainable, very complex, production-ready agentic systems. And we're still trying to figure out exactly how to do that right. But there are a smattering of examples of people who have plugged agents in. I'd look to Agentforce to see.
Yeah, and I like following the LangGraph and LangChain blog. There's some case studies up there. We'll drop in the chat. They're highlighting some of their customers' best work that they can talk about. And so, we are hearing some murmuring, some whisperings, but it always is important to ask, like when you hear somebody that has deployed an agentic application in production, it's like, what do you mean by agent exactly? What is the agentic behavior and how often is it being leveraged? And is that the right solution for the problem? Could it have been solved with a simpler, more straightforward RAG application that's going to be a lot less cost, intensive, but potentially just as performant? There's a lot of interesting questions when we get into this space that we're going to continue to track for sure. Finally, how is the best way, if we're playing with this, to debug a swarm agent? Can you do like traces? Can you set up kind of the same kind of WAN-B, Langsmith kind of thing, if people are familiar with that? Is there anything baked into OpenAI's framework, or you got to kind of set it up yourself?
This is an educational, non-production framework. Tracing is an afterthought. If you want it, you have to do it yourself. What I will say is that it should be fairly straightforward through things like Langsmith or tools like WAN-B, though you're going to have to build it yourself. Yeah.
All right. Killer. Thanks for walking us through Swarm. I think we swarmed the frameworks today. I think we got some good takeaways, and we'll see you back next week, Wiz, for Mixture of Judges. Make sure that you do RSVP for the next week's event so you get those reminders. It is the latest and greatest from Meta that they're sort of saying, I'm pretty sure we just took RLHF to the next level. It's kind of a big deal. Not a lot of people are talking about it, and it looks really, really cool. Very technical. If you're into alignment and fine tuning, check this out next week with that. If you are new to AI Makerspace, we'd love for you to jump in the Discord and start building, shipping, and sharing with us in our community today. And if you're interested in joining an upcoming cohort, what we've got in store for you next is LLM Engineering, the Foundations. This launches in just a few weeks, Cohort 3, where we dig into the details of the transformer architecture, what's exactly going on inside, how do we do training in the first place, how do we do fine tuning, how do we do alignment, how do we think about some of these more complex, more state-of-the-art techniques like merging and like distillation, and how does all this come together into the state-of-the-art models we're seeing come out on the market today. That's what we get into in LLM engineering, starting from first principles and from scratch. Submit your application today. If you're interested, you'll have a free challenge that will get you fine-tuning your first model if you've never done that. For more on Crew AI or LangGraph or workflows from LlamaIndex, you can always check out our awesome AIM index. It's a really easy way to navigate all of our content. It's starting to become quite a lot. But if you're interested in multi-agent systems and you haven't checked that stuff out, go ahead and dig in today. And that is officially a wrap. Wednesday, October 23rd, Swarm from OpenAI. Please leave any feedback you have on today's event and upcoming events you'd love to see in the chat or in the feedback form. And as always, until next time, keep building, shipping, and sharing, and we will most certainly do the same. We'll see you back next week. And also, don't forget to join us for Demo Day, Cohort 4, tomorrow, live on Zoom. Check out what folks have been working 10 weeks to build, ship, and share. We'd love to have you there and support our community. All right, that's it. Keep building, shipping, and sharing. We'll see you next week. Bye, everybody. Have a great one.